All right, so in section 4.12, we're going to be looking at stretching horizontally sine and cosine curves. And if we get to the end, we'll go ahead and do tangent as well. So what I'd like to start with is just a quick little review on just general transformations that we've been doing this year. If I'm giving you a graph called g of x, I would like to know what happens if I then ask you to graph g of 2x. Right? Well, inside the function it says x times 2, so our rules would say to divide all of your x's by 2. So this would be a horizontal compression if we're trying to put it into words or describe it, right? The graph is going to shrink horizontally because all of the x's will get cut in half. On the second one, if we had g of x divided by 2, again, because it's on the inside, we would do the exact opposite and we would multiply all of the x's by 2, which means for us this would be a horizontal stretch. The graph would get longer horizontally. Okay. So we're going to apply that to our sine and cosine and tangent graphs as well. So first thing I'm going to do is just a quick little review of our parent graph. I'm going to do that in a black pen. A sine graph, this is for the regular sine graph, starts at 0. At pi over 2, half of pi, we're up at 1. Come back to 0. At 3 pi over 2, we're at -1, and 2 pi, we're back at 0 again. So just very lightly, I'm drawing in the parent graph of sine. And you know what, while we're there, we can just go ahead and do it down here as well. Very, very lightly, just drawing in that parent graph. Okay. Well, I would like to graph the sine of 2x. So we're going to divide all of our x's by 2. Well, 0 divided by 2 is still 0. Pi divided by 2 will be pi over 2. 2 pi divided by 2 is 1 pi. So there's my 3 zeros. This maximum is at pi over 2. If I cut it in half, it's now pi over 4. And this one gets cut in half, 3 pi over 4. So we've taken this sine curve and we've cut it in half horizontally. So we could just keep going, right? We could just repeat that pattern as many times as we need to. Could go in both directions. It's a periodic graph. Okay. All right, let's go to the question. What is the new period length of each graph, right? So I want to answer the period, and we'll answer how many complete cycles could be graphed in the original interval. I'll just say number of cycles. So for this graph, what is the new period? Well, remember that first graph I drew was right in here. That S shape finished by the time we got to pi. So the new length of the graph is pi instead of 2 pi, which makes sense because we cut the x's in half. And my original interval was 0 to 2 pi. How many complete cycles did I graph? There's 1, 2. I graphed 2 complete cycles in that same amount of time. All right, well, let's do the same thing with this second graph. This is the sine of 0.5x, which we know 0.5 is the same as 1/2. So I have the sine of 1/2 x, which could be written as the sine of x divided by 2. So just like that opening slide, if they're saying x divided by 2, we're going to multiply all our x's by 2. Well, 0 times 2 is still 0. Pi over 2 times 2 is pi. This pi times 2 is now 2 pi. So there we start to see that top half of that graph. This was 3 pi over 2, so when I double it, it's just 3 pi. And then this point was 2 pi. When I double it, if it goes off our graph paper, 1 pi, 2 pi, 3. I'm just trying to keep the scale the same. 4 pi. So that ending point got shoved all the way out to the edge here. I still want to answer those same 2 questions. What is the period length and what is the number of cycles? Well, look, I just did that. The period length of this graph, we're going from 0 to 4 pi. The number of cycles in that original interval, well, let me grab my green pencil here. There's 0, there's 2 pi. I didn't even get a complete cycle. In fact, I only got half. of a complete cycle in. Okay, but that's exactly what I want to look at, right? The sine of 2x, we were able to graph 2 cycles. The sine of half an x, we're able to graph half of a cycle in that same time. Okay. So this idea leads us to this concept of angular frequency. When we're graphing a sine or cosine curve and we've got a multiple with the x, the letter B, the multiple with the x, represents what we call the angular frequency, which is a fancy way of saying how many complete cycles did you get in between 0 and 2 pi. Okay, so let's take a look. I'm actually going to do these graphs in reverse. So I want to do this one first. Here's 0 all the way out to 2 pi. I'd like to know what its angular frequency is and its period. So it's a sine graph, so I've got 1 complete cycle, 2 complete cycles, 3 complete cycles, we'll go back to red, 4 complete cycles. So I was able to fit in 4 graphs, which means my angular frequency is 4. The period length, however, is just how long did it take to do one of those cycles. This graph started at 0 and it ended at pi over 2. Let's do the same thing with this first graph. Again, we're starting at 0. There's 1 sine graph. There's 2 sine graphs. There's 3 sine graphs. So again, my angular frequency, how many of them did I get in by the time I got to 2 pi? That's 3. In terms of the period length, that's a little bit trickier because this purple graph sits between 0 and this, I don't know what that number is, right? It's not as straightforward as this one where we saw where it ended. But remember, this whole length of this graph is 2 pi, and we've cut it into 3 equal pieces. So the length of each one is 2 pi divided by 3. By the way, we could have done that here, right? This whole length of the graph is 2 pi, and I cut it into 4 pieces. Well, 2 pi over 4 reduces to pi over 2. So that relationship that we're looking with between the angular frequency and the period is 2 pi divided by that angular frequency. This is a big deal. Let's put a bunch of stars around it or highlight it or whatever you need to do. So to find the period length, we need 2 pi divided by b, where b is the coefficient inside a sine or cosine curve. Okay. All right. So it says for each equation determine the period length. And just for time purposes, we'll skip that one, but let's do these 3. So here's a sine curve. Again, to find the period, we just need that value for b, and b happens to be 4. So the period equals 2 pi divided by 4, which reduces to pi over 2. Okay. This next one, well, the first thing we need to realize is if you want to see a coefficient, we have to write it a little bit differently. X divided by 3 is the same as x times 1/3. So here's my value for b. So the period equals 2 pi divided by 1/3. Well, we know dividing by 1/3 is the same as multiplying by 3 over 1. So we get a period length of 6 pi. We'll skip this one. We'll do something like this next, but let's take a look at this one. We have x times 2 pi over 7. There's my value for b. So the period is 2 pi divided by 2 pi over 7. Or let's flip and multiply by 7 over 2 pi. We can reduce our 2 pi's and we're left with 7 over 1. Okay. All right. So let's do a little bit of graphing. So it says graph at least one period of each. clearly label each axis. So I specifically, or I purposely, I should say, did not give us graph paper like I did yesterday or on Friday, because we're going to be changing the scale on the x-axis. So it's actually better for us if I don't give you actual graph paper. So what I notice here is that I've got a cosine graph. I also notice that I've got an amplitude of 5, or a vertical stretch, same thing. Well, let's write that down. Vertical shift, there is nothing at the end, so we could say it's 0. We could also say not applicable. There is no vertical shift. So if you want, you could say, well, that midline is now on 0. And if the amplitude is 5, that means we're going to go up 5 from the midline or down 5 from the midline. The period is going to be 2 pi divided by b, and b is pi over 2. So if I flip and multiply, the pi's cancel, and I'm left with a period of 4. It's actually nice for us. So that means the length of the graph is 4. If we're starting at 0, that means we're going to end at 4. Halfway then between 0 and 4 is 2. Halfway between 0 and 2 is 1. So 0, 1, 2, 3, 4. It's a nice way to break up the x-axis. So now it's just a cosine graph, and we saw on Friday a cosine graph starts at the top, comes to the midline, goes to the bottom, which is -5, back to the midline, back to the top. It's like a hill you sled down, make your little parabola, and then repeat. Okay? Good. Let's take a look at the next one. It's a sine graph. This time, and I didn't ask the same questions, but this time my amplitude is 1 and my vertical shift is 4, which means the whole midline is going to go up 4. And because the amplitude is 1, that means I'm going to go up 1 from 4 and down 1 from 4. Not a great scale. It'd be hard for me to squeeze in a 1 and a 2, but that works for us. Now, they're asking 2 questions. What is the angular frequency? Well, remember, angular frequency is just the number. That's that b. It's just 3. The period is 2 pi divided that number. So 2 pi divided, well, there's nothing to simplify there. 2 pi divided by 3. Which means when I start at 0, the length of the graph is 2 pi over 3. That means I'm going to end at 2 pi over 3. Well, we've cut that in half to find the middle. Half of 2 pi over 3 is just 1 pi over 3. Then I want to cut that in half to find the middle of these two. Half of pi over 3 is pi over 6. Which means this distance here is pi over 6. So 1 pi over 6, 2 pi over 6, which reduces, 3 pi over 6, which reduces to pi over 2. And then 4 pi over 6, which reduces to 2 pi over 3. That's us labeling the axes. But all we need to do now is draw our sine graph in. Sine starts on the midline. At the first tick mark, it goes up to 1, comes back to the midline, down to -1, and then back to the midline. And there's our graph. Okay. All right, last one we're going to do today. It says, without graphing, answer the following questions about this function. They're asking for the max value, the min value, and the angular frequency. Remember, angular frequency is that value for b. Well, look at that. b is 4. So really, I'm just trying to confirm some vocabulary here. Now, I want to know how high does the graph get, how low does the graph get. I don't want a graph. But this information comes from the vertical shift and the amplitude. So if my vertical shift is 100, that means, I'm not graphing, that means I'm going to go up 100, there's my midline. If my amplitude is 20, that means from the midline I'm going to go up 20 or I'm going to go down 20. So if I go up 20, the highest I'll ever get is 120. And if I go down 20, the lowest I'll ever get is 80. So I didn't need to graph. I'm just reminding us that maxes and mins come from the vertical shift and the amplitude combined. So we're going to stop there for today, and we'll pick up with tangent tomorrow.